Okay. So, hello everyone. This is Gopal Krishna from ECE Department, PS University, and I will be the one who will be hosting this meeting, the workshop on Fusion 360. So, still students are joining. So, I'll just wait for one more minute, and we'll just begin the workshop. Till then, can you just raise your hand if anyone of you guys are familiar with 3D modeling or Fusion 360 or any kind of a software? Anyone? Okay. So one student. Anyone else who are familiar with 3D CAD modeling? Yes, great. Okay, so yeah, so there are some students who already know some of the basics of CAD modeling. So, anyways, right. So the agenda of today's workshop will be to know what's CAD modeling, and the workshop will be mainly concentrating on 3D modeling required for robotics and not for like full-fledged 3D design workshop. It's not a full-fledged 3D design workshop, right? So hope you get the point, and let's begin. So I'll share my screen. So yeah. So yeah. Still people are joining. Fine. Yeah. Okay. So is the tab visible to you guys? Can someone just raise your hand if it's visible? Great. Thank you. Thank you. Thank you. So today we'll see the software called Fusion 360. So this software comes from a very well-known software developer called Autodesk. They have a whole variety of software for CAD modeling, animation, and much more. So coming to the Fusion 360, it's not just a CAD modeling software, it's more than that. So we'll see what else you can do from this software. And yeah, so when I was selecting the Fusion 360 for the CAD 3D modeling workshop, so some of them had a question that why Fusion 360, why not some other software like AutoCAD, right? So Fusion 360 is a much easier 3D modeling software, and some of them might agree, or some of them might disagree too. But on top of that, this software also allows you to design CAM, which is for CNC machines, and PCB, which is a complete uh, electronic circuit on a board. So it's a complete different thing. But yes, nowadays, as we know, electronics it's everywhere, and we need printed circuit boards to actually get our electronic projects. Even if it's a robot, if you want to get into the market or make a product out of it, you need a PCB. And if you have a PCB designing software integrated with something like this, which the Fusion 360 gives you, the advantage is that you can import the 3D model of your PCB and integrate with the enclosure or the mechanism, whatever you have, right? Fine. So let's see how you can get started with the software. So coming to this website, which is autodesk.in.campaign, slash campaign slash education slash fusion 360. So here I would like to mention that please don't use any kind of pirated software for Fusion 360, as you guys are students or educators, you can get a free version of Fusion 360, right? So you can get a free version of Fusion 360. How? So what you need to do is just like press on like get Fusion 360, and this thing will take you to another tab where you need to select the software which you want to download. So it's getting loaded. Fine. So as you can see here, you have the Fusion 360, and when you press on this get started, just select the role. So basically, most of us are students. So select as a student, select your date of birth, just randomly select something. Right. Okay. You will be prompted to a window where you need to fill your details, right? And to get this free education license, you need a receipt or your marks card. So basically, your ID card will work if you have a date on it. So you need a date, like the expiry date or the date at which you'll complete your degree, right? So you need that kind of documentation to get this thing verified, or you can use your college email ID to get it verified quickly, right? So fill up the details and create an account and download the software, right? So let's see how the software looks like. I have already installed the software. I share my screen. And if you guys have any kind of a doubt while teaching, while showing the Fusion 360 software, just you can just raise your hands, and I can clear doubts, right? If any. Or at the end of this workshop, we can look at your doubts and whatever you have in your mind about the workshop. Right? So here's the Fusion 360 software, which is pre-installed in my laptop. I'm just opening it. And yeah, the most important point which I want to make here is Fusion 360 is quite a bulky software. Basically, it requires very good hardware configuration on your laptop or a PC, right? So make sure that you have a good specs on your laptop or a PC. So yeah, so it'll work, but there'll be a huge delay, as you can see. So still it's getting loaded, right? Okay. So yes, we are now into the software. So when you install it, you will be prompted to a login page. You need to log in with your email ID and password sent to your email ID given during the registration, provided during the registration, right? So yes, so when you do the login, you will be headed to this page. So as you can see, untitled, a new file is open by default. So initially what we'll do is we'll just save this file, right? Save it with, like, I'll just save it as Robofest 1, something like that. And you can also select location. As you can see, this location shows as admin project. So what this means is, or like this means to, they are actually, the Fusion 360 is a very good, it's a very good thing to have this kind of a feature in a CAD software, which is cloud storage, right? So this admin project, whatever I'm selecting, you can definitely select local device storage. could have selected admin project, which is a cloud storage available free for you. Definitely it has a limit, but yeah, if you cross that limit, you can store it in your local drive. So I'll just press save, and yes, so you can see Robofest 1 version 1 version 0, right? 1.0 something, version 1. So let's start building something, right? So so as you can see at the top end, we have a cube kind of a structure which you can use to move towards the grid. So this is called as a grid, right? And I hit the top, and this is what I like to use. You can use any grid, right? So I'll just hit top grid, and let's start. Okay. So when you start your sketch, you just need to hit on the sketch part, and you will be prompted to this window, and you need to select a base, right? So basically, I need to select a plane. As you can see, select a plane or a planar face to start a 2D drawing, right? So basically, 3D CAD modeling is nothing but drawing it in 2D and extruding it. So what is extruding? We'll see in the coming part. I'll explain you what is extruding. So right. So we need to have a 2D design initially before making it into 3D. So in the left corner, you can see some of the pre-made designs, right? And yeah, so let's see what we can get here, right? Okay. So yeah, as you can see, you have too many options here. If you click on the drop-down menu, you can draw lines, rectangular, circle, arc, polygon, ellipse, right? So too many options here. So I'll just select circle to just show the demo, right? So when I click on the center, see, it's a practice that we take like center, like we just take the center of the grid as center of a 2D sketch. So you can select any center. So as you can see, when I just clicked on it, so I'm able to draw a circle, right? And when I'm extending it to using my mouse, so we can see there's a change in the diameter of the circle, right? So this is the diameter, not the radius, right? So let's draw a 100 millimeter diameter, which is a 10 centimeter, right? So what we could do is we can just directly type like and see if I type 100 and press enter. So here I'm able to have successfully drawn a 100 millimeter circle, right? So it's a 2D sketch, simple sketch, right? Fine. So let's take an example to extrude a cup, right? So a simple cup, a cylindrical cup, which has a bottom, which has a bottom closed and which has a hollow inside, and top side is open. So what I'll do is I'll just select a center and draw a second circle. So this thing, like we need to keep some offset, right, from the first circle. So I'll just keep it as 80. Press enter. So and the which you can see here, you can actually delete this, the measurements just given by default, right? So now it looks better. Okay. So I'll just finish this sketch, and yeah, so you're basically done with your 2D sketch. So this is not filled from any viewing angle. So we need to make it 3D. How? So there is an option called extrude. So there are two options, majorly two options. One is sketch, where you do the 2D sketch, and you have an option called extrude, where you will convert the 2D sketch into 3D. And you can control that what at what extent you want to extrude. So if you can see, I have selected area. So you can select area when you select this extrude thing, the option. You need to select area to extrude. So when I press on this area between the bigger circle and the smaller circle, and here you get a input for the thickness, right? Or you can say the height of that cylinder. So I'll just select it as 30, which is 3 centimeters, right? And I hit enter. And basically you have a cylinder. So now if I want to create a base for the cylinder, what I'll do is, so here, hit on sketch. So if you can see, after extrusion of your model, the sketch is hidden. So what you can do is you can just unhide this, right? Select the extrude option, select the area which you want to extrude. So this will be like 5 millimeters. And we have a 3D structure. So yes, so it's a very basic 3D structure. We just converted a 2D design into a 3D design, right? Okay, so we'll just remove this and we'll look into something very much useful. So we'll take a use case from now onward, which will be robotic arm, right? Very popular nowadays. People are building robotic arms, right? And it's pretty hard if you don't know something like 3D CAD modeling. And if you go to website like Thingiverse, as you can see, hope the screen is visible, right? So as we can see, we have a website called Thingiverse, very popular, and a GraphCAD. Students often go here, download 3D models, and they 3D print it. Problem with this thing is it's really hard to edit these CAD files, right? If they are in the exact shape, it's well and good. You can download and you can use it, but you don't get the idea behind the design, which is a really bad thing, right? If you run into some issues because it's a mechanical stuff, it's a hardware, you will encounter some issues while building it, while assembling it, and while running it, because there are motors and you have pulley structures, gears, and everything. So there will be some issues, and troubleshooting these kind of 3D models which are available uh, for like pre-made stuff, like designed by someone and upload it, right? So it's pretty hard. Yeah, if you have a Fusion 360 file, which is f3d.f3d file, it's easier to modify that file. But most of these websites provide you STL, or like you can get any kind of a file format, but they will give you a 3D printable file format rather than a 3D editable file format, right? So let's see, can we design one of the most important part of a robotic arm, which is this. If you can see it closely, I'll just open one of the projects available in Thingiverse as a reference, right? It's a robotic hand made out of servo motors. So there are there are three servo motors, and there is a base servo motor, right? Totally four servo motors, and at the end effector part, we have a single servo motor, and we have something like a gear structure, right? Which looks a little complicated. And so that's why what we'll do today is like we'll try to design a gear structure like this, how to design it, and how we can actually make it ready to get that thing 3D printed and which you can incorporate in your project. Right. So let's go back to Fusion 360. Right. Okay. So we are on our grid. So whenever you start your project, just save that project. It's very important because whatever you do, as I already told you, whenever you press hit save on it, right? If it's stored in your admin project, so it will be stored on the cloud. So you won't miss that file, even though if you have any power cut or something like that, right? Fine. So let's design a gear, right? Very basic gear, which is gears are the most important part of robotic mechanisms or structures. The gears everywhere in the mechanical structure to move things around and distribute the torque and stuff, something things like that. We do have gears inside a motor, and as we are building a robotic hand or a robotic hand end effector, what we technically call that thing, basically a structure which can pick and pick object, right? Something like that, which we saw on that Thingiverse project. So designing the gear, you can start with just taking a circle, which we did, right? You can just type in the diameter of the circle, and you can start. Basically, you need 3 circles to draw a gear structure, which is which will look something like this. What people do is like the people who do the design stuff, like the hardcore 3D design CAD modeling stuff. So what they do is they design a single piece, right, the tooth of the gear, and they multiply it across the circumference of the circle, and they extrude it. It's a pretty complicated task to actually do, right? So what we'll do is, so Fusion 360 comes handy here because we have pre-made tools available. So what are those pre-made tools? So here at the top section, you have this option called Sketch. If you press, okay, right. So you have all these options: Sketch, Surface, Mesh, Sheet Metal. So these are the options or tools available to build your 3D sketch, right? So what we'll do is make a custom gear structure. So we will select 2:1 gear ratio to make a gear structure, right? So we'll just select some of the bits on the three main option called add-ins, and you'll get this window in add-ins. So here, if you scroll down, you have something called spur gear. So this is what we want. So basically, you can select any of this, a spur gear, a Python version, or a C++ version. So basically, this thing, the CAD models can also be built using curve structure. Looks pretty hard, but if you get used to it, so it's quite easier to do with code base rather than like visually doing it, right? Today we are doing it visually. So let's see. We'll just select spur gear, and I'll just select Python, or you can even select C++. You'll get the same results. And we'll hit run. So here there is an okay. So there's a pop-up from Fusion 360 that spur gear sample added to your tool section, right? So if you go to the solid create section, you have this option available because we have added it per gear, right? I actually added it before this workshop. So what we'll do is we'll just import that thing, or we can just select it from here, or we have a shortcut key, which is S. If you just press S on your keyboard and you can search for gear. Yes, here's the thing. So here we have a window, right, available to us to actually get a gear, mechanical gear. Right? So yeah, the first section shows. So here you can see they have drawn gear structure. They have shown some parameters which you can change here to get your own gear, right? Gear structure or the configuration you're looking for. The configuration might be the number of teeth, right? The backpack, the root filter radius. We'll see what all those parameters are. And here, two of the most important parameters they have mentioned, which is a pitch diameter and a root fillet radius, right? So don't worry much about this because we are not looking into the 3D design stuff more, right? We are looking into more into the 3D design aspects rather than these mechanical aspects, right? So metric is standard which we select basically standard for units, and the second like it's a default thing, the fifth thing. After this, you have something called pressure angle. So pressure angle again, it's a standard 20-degree pressure angle which we even you can use 14.5 degree. It depends on your project need. 20 degree is the most widely used pressure angle thing. So pressure angle, to be specific, so this is an angle between two gear teeth, right? So if you have a gear structure, you have two or more gears, which will basically transfer the rotational movement to from one gear to another through these teeth structure, right? So 20 degree is the pressure angle used by default in the engineering structures what we built, right? The third one is the module, right? Here, it's before going to that, so this number of teeth and the module, these two are the most important parameter of your gear structure. So these are the things which actually determine, of course, yes, you should define what are the number of teeth structure, or like what are the number of teeth you need in your gear structure, right? So for example, I'll just select 34. Like we'll just select 30, right? So if the tooth number of teeth is 30, and as you can see, a pitch diameter is by default generated. So I don't have any control on this pitch diameter. So what is pitch diameter? So can you see this? I think you can see this line drawn here, right, on this image. So this is called pitch diameter. So basically, this is not the actual diameter of your gear, but it's a diameter taken from the center of the teeth, right? So basically, it determines the size of your gear structure. So definitely, we don't want this big, which is like 381 Basically, it's 38 centimeters, right? It's pretty big. So we don't want that. So what I'll do is I'll just change this module to like something like 2. And there's a error pop-up. You can see the root fillet radius is too large, right? We'll get to that, right? But when I made it to, it's a complete trial and error. So you can change this module thing, right? And basically, technically the module is the ratio of pitch diameter to the number of teeth, right? So we have the number of teeth, and we know what the pitch diameter is, and which is auto generated uh, at the bottom, which you can see. When I made it two, like let's say if I make it one, so it's giving me 30 which is quite small. I'll just select it as two, 60 basically looks pretty promising, so I'll just select it as 60 So based on your requirement, based on the diameter or the radius which you're looking for, you can calculate and you can select the number at this module thing, right? The number of teeth and the number of modules. And coming to the backlash. So some of the parameters what we look here should be default parameter. If you're and the point which I need to make initially while starting this workshop was we are more targeted towards making 3D structures for 3D printing purposes, right? So for most of the 3D printers, like have very good like basically settings. It works well with 0.15 backlash. So backlash, to be specific, is the clearance between the two like teeth of the teeth of the two gears. Basically, definitely we'll be making two or more gears, right? Not a single gear. We'll be making a structure with we'll be making a gear structure. It will be 2:1 or anything like that. We'll just select as 2:1, right? So and you have okay, we are done with the backlash. Basically, it's the clearance, right? So if it's 1.15, so the total backlash for a single T will be 3 Oh, sorry, 0.3 right? The next thing is root fillet radius. It's something. Just a minute. Yeah. Okay. So the root fillet radius, if you can see at the bottom, we have a pop-up that root fillet radius is more than it should be. So it's a practice that we keep the root fillet radius 1 or less than 1. So basically, it's the radius of this curvature which you can see. So I don't want to make it more technical, right? So we'll just fast forward this thing. And the next parameter which we can control is the gear thickness, which is I think 1 centimeter. Like I just keep it 10 and the whole diameter is 10 which is 1 centimeter. And if I press OK, okay, so right. So I'll just zoom out, and we have a first gear. So it's a mechanical gear with total number of like the number of teeth were 30, which we selected. So now we need to make a structure with this, basically a gear structure, which I told you, which will be like 2:1. Based on your application, you can select it. So what I'll do is, so you can take a look at it, at how the 3D model looks like. So a 2D design converted into a 3D object, right? So now, if you want to replicate this, right, it's pretty easy. Just select this thing, go here, and right. So what you can do is you can replicate this thing. So I'll just hit on shortcut and spur gear. You can see that. Just select that, and as you can see, all the settings which we made are same. Definitely, we need to change the number of teeth because we are making it 2:1. The ratio of the gear ratio will be 2:1. So I'll just make it 15 half, right? And we need to also divide the root fillet radius by half, which will be 0.5. Okay. So everything else will be same. And if I hit OK, as you can see, we have a 2:1 gear ratio setup. Yeah, by default, the second gear will be in like on top of the first gear. So what we can do is we can just select this thing and hit right click on this, select move, and yeah. So
Excuse me.
yeah,
How do we replicate the gear?
yeah. So okay. So replication of the gear, as you have seen, we already have a tool from Fusion 360 where we just need to input the parameters and we'll get the gear out, right? So on your keyboard, if you press S, if you can see a pop-up window came out, and if you just search that per gear thing and select this, you have all the parameters which you selected previously. You can change the parameters for the second gear, second or the third gear, whatever you want to generate, right? You just basically, as I told you, I plan to make a 2:1 gear ratio. So what I did is I just divided it by half, like divided by two, the number of this tooth ratio and this root fillet radius, right? If you do that, you'll get the gear at the center, right? And if you want to move this, you just select this, hit on move. Okay. So wait. What I'll do is I'll just magnify this thing and I'll just select this, right click, and I'll tap on move thing, right? Just a minute. So I'm just stopping the my screen sharing. If you have any doubts, you can ask till then. I just have some problem with on this thing. I'll just see what's the issue. Till then, do you guys have any issues? Till now, have you? Do you have any doubt
Yeah,
on the?
yeah, I have one
Yeah.
doubt. Is there a
Mhm.
way to import Fusion 360 files onto SolidWorks?
Yeah, possible. What you can do is there is an option which I'll show you definitely. The file, whatever you design in this Fusion 360 software, you can export it into any extension, like
Okay.
even in like STL, F3D, or any standard file.
All
So
right.
I think SolidWorks that extension is quite popular, and definitely you can
All
get
right. All right.
you can export that thing.
Okay.
Right.
Yeah, hi. How do I change the gear parameters again? Like after
Okay.
creating the gear, how do I change the parameters?
So after creating the gear,
Yeah.
okay. See, if you want to change the parameters, you can directly select that model, right? Right click on it, and you will get a option called Edit Profile Sketch, right? So when you click on that, so you'll be prompted to the window which you previously edited, and you will have all the options which you selected, the teeth, the gear, basically the number of teeth and everything, like the pressure angle, everything. So you can change it and you can click OK, and all the parameters will be changed as per the selection. So basically, you need to right click on it and you'll get all the options. Anything else till now? Any doubt? Okay, I'll just share the screen. Hope now it's visible, right? So this is the gear structure which we design, right? And if you want to create multiples of this, as I told you, you can just press S on your keyboard and you'll be directed to, like, you'll get this pop-up window for search, right? And if you search that for gear, and you can modify, like, basically modify the parameters which we had before. If you can see all these parameters which we had before, right? So basically that's what you can do, and click OK. You'll get that gear, and you can set up basically even the Fusion 360 has a feature where you can actually get all the gear and set it in a particular fashion, and you can simulate it, so which is very helpful before 3D printing it, right? So basically, you can see how the rotation will take place, the pressure point, is there any heat generated? So basically, Fusion 360 is a complete package of design and simulation software, right? So what we'll do is, actually we are running out of time. So what we'll do is, we'll show, okay, so this is the 3D structure. If you want to export this 3D gear structure, you can, as I told you, you can design multiple gears and you can place it, and you can make a complete mechanism, see the function of that mechanism, right? So for now, what we'll do is we'll just see what all options we have after designing the 3D structure. First, we need to hit save, right? So you can give versions for whatever you design. So I didn't give any versions, so you can do that if you want to, right? And if I want to export this 3D file into some well-known file format, basically, if you want to 3D printer, it's recommended to use STL export. And the thing which someone asked, that how you will export it into different file formats. So it's a cloud service, okay? So you need a active internet connection, and when you hit on file, export, select the file, and you can select the file format in which you want this 3D file to be in, right? All major file formats like OBJ, SMT, STEP, STL. So if I hit on STL and selected downloads as my path to get that thing and hit on export. So there is a cloud service which is free for some extent. You have a daily limit to convert your files to STL or any other file format, or you can download your file format in a 3D format for free. It's unlimited. So I'm just converting the file which we just designed into a 3D file, an STL extension file, which we can use to 3D print it, or take this file to a 3D slicer. So are you guys familiar with 3D printing? Anyone? So it's taking quite a lot of time to get the get this thing exported. We'll wait for some time. Till then, if you guys have any questions, you can ask, please. I'll just stop sharing. If you guys have any questions.
Excuse me.
Yeah.
When would the problem statements be given?
Okay, I'm not sure about that. Wait. I think there is a coordinator in this meeting. I'll just see. I'll just check. Yeah, you'll get that. You'll get update on that in the WhatsApp group. You're in the WhatsApp group, right?
Oh, yes, I'm there in the
Yeah,
WhatsApp.
yeah, you'll get update on that.
Fine. All right. Thank you.
Yeah. So, do you guys have any design or something like that which you wanted to design and you might have a problem? Like I have shown some of the basics, but definitely they won't cover each and everything which you need to get 3D printable structure, right? For your robot, something like that. Anyone has any questions on structures which you had in your mind and you want to design? So we'll also look into an example of a enclosure, right? We'll try to design an enclosure and a chassis very fast, and we'll see how we can do that. We'll just check whether the file is exported. So yeah, and that this file export thing depends on the internet speed, whatever you have, right? Taking more than expected. Fine. I'll just start with continuing the workshop with a different design. Right? So I think it's visible, right? So this was the gear which we designed, and we tried to export it into STL. And I'll just open another file. Okay, so as you can see, still it's converting the file into STL format. I'm not able to do anything else till this thing gets exported. Okay, it's taking more than expected. So what I'll do is I'll just cancel the process and I'll just close this thing. Right? And that thing we'll say later that basically that's the procedure what we need or what you should do. Select your file, go to export, select your file format, uh, and the file location, and hit on export, you will get the file in the selected format, right? So let's see how we can build a chassis, right? So very popular structure of robot chassis are stack structures, right? You have circular or rectangular plates and or square plates, and you have stacked one like you get a structures like plates stacked one upon another, and you have spacers to help them keep them in stack and in a specific place, right? To basically raise that thing to a specific height. So what we'll do is we'll just design a circular chassis base. I'll just keep it 100, press enter. You got this, right? Get another circle. I'll just make a 10 mm hole. What I'll do is I'll just make some holes on all four sides of 10 mm. Why? That we can see. Okay, so if you have someone had a question that you have this design, right? And now you want to change the parameter. So what you can do is you can just click on it, right click on it, and you can see sketch dimension, plot it, and now you can change the parameter, right? So for example, if I say if I want to make it 20, hit, so you have this diameter to be 20 millimeters, which is 2 centimeters, and you can just delete that thing, right? Even this thing. So yes, so even like instead of designing like individually, what you can do is, as we can do it in a document, you can just hold on this, right click, copy, and you can move this thing. And if you press Command V, okay, so it's okay. So what you can do is you can just press copy paste, and you can move this thing. And here you have another copy of the same circular, like same circle with the diameter of 10 mm, right? And you can just repeat this thing, paste. So basically, what I want to do is like I want 4 holes of 10 millimeter diameter. And if you want this thing to place precisely, right, please don't use the technique what I am using, like holding this block and moving this, right? What you can do is you can use this grid, like basically this grid value, which is, for example, if I want this thing to be exact at 40 mm, which is minus 40 mm, I'll just type it minus 40, or I think, okay, right. So minus 3 or minus 4, something like that, right? So basically, you can precisely place it. I just type minus 4, and if I hit enter, so we can get to a specific area of a grid rather than simply holding it and getting that thing to a particular position. So you can just right click, press move. This is what you can do. You can do the manual movement too, right? And hit enter. So I'm again copy pasting the same thing. So 4 holes at the 4 ends of a circle, right? So kind of a 2D sketch is ready. So what we'll do is we'll just hit on finish sketch, and we have the 2D sketch. And we want to extrude this sketch. Okay, we want to make a circular plate with 4 holes where we can put spacers in it, right? And make a stack up version, basically a stack version of a robot chassis. So what I'll do is I'll just select the area which you want to extrude. Basically, if you can see, I can select area, right? So if you want to select multiple areas, like command select, you can select multiple areas which you want to extrude. But no, I don't want these things to be extruded. basically convert. I don't want to convert this thing to a 3D format. I want to like basically keep these things hollow, because they are the holes for like mounting holes or mounting holes for the spaces, right? And I've selected this, hit on extrude, you'll get this window. Type anything. For example, I'll just type in 10. So here the unit which we are using throughout the workshop is millimeters. Hit enter, and you have this. You can design circular, triangular, or any three-wheel structure, right? Structure, 3D structure. Basically, I'll just undo everything. I'll show you how to design custom design by using this line tool. So basically, what you can do is, if you want a parallelogram, if you want to draw something like that, right? So what you can do is use this line tool. You can see when so when I select this line tool, I need to select a origin or a dot, right, on this grid for my reference. And if you see this, basically you can type in the length. I'll just type it 40 and just place it at the angle at at the angle where you want to place that line, and just press enter. And after this, if you can see, you can continue this sketch, right? It's not like it's done. Like we'll just continue. I'll just select an angle of it's like 50, 60 degrees. You can actually control that angle too. So I'll just select a random angle, and I'll just close this sketch, and yes. So here we have a structure, a 2D structure, which is different from a square or rectangle. It's a geometrical structure, right? You can do changes as per your need. Basically, if you want a block or a 3D structure in this, yeah. So if you want a 3D structure of this 2D plane, what you can do is, as we did in the previous thing, basically select finish sketch, extrude, select the extrusion rate, which I just select 30, and you have a 3D block. So, okay. Do you have any doubts in the sections which we just cover right now? Any questions? You can use the combination of square, lines, circles, arcs to create various structures, right? Make a 2D plane of on this grid plane, make a 2D sketch of it and extrude it. And if you want to actually make holes at multiple, so as we know, this is a 3D structure, right? So I only taught you about a single plane. So what you can do is you can even select, you can make basically I'll just show you what I'm talking about. So I'll just select okay. So we'll just draw a rectangle, right? So this thing is on a plane called top. So this is the top plane. If you want to draw something at the front plane or a different plane, what you can do is you can hit on sketch and you can select a different plane, right? So if I select this plane. And if I draw another rectangle, and now you can see I'm drawing things like 2D sketch on a 3D plane. So you can do the extrusion, you can make holes on different planes, basically a single structure with multiple planes. So this can also be done. So it'll be a little complicated. For complicated structures, you need this. You need multiple planes to sketch to make sketch of your like basically make the 2D sketch for your model. So any doubts? Please do ask if you have any questions. So are we done? So like this is what all about introduction to Fusion 360, right? So if you have any doubts, you can ask me. Anyone, please. So I'll just finish this workshop in 1 minute. If you guys have any doubts, you can just ask me. So anyone, guys, because you guys will be using this software to design files for building your robot or any kind of a mechanical structure, right? Okay, great. So there are no doubts. At last, I'll just want to show you something which I forgot to. So it's not possible for me to show everything like designs from scratch, some complicated designs. It's not that It's not possible. I'll show you some of the designs which were made by me. Uh, okay. So this is a box enclosure made for a particular specific project. So in my final year during the COVID, so we actually had built a contactless temperature sensor, and we made it quite compact. Basically, it was a contactless temperature sensor, which was capable of uh, getting connected to your smartphone. And this was the enclosure which we designed, right? So this is and we use this design as template for most of our projects. So basically, if you see, it's a very complex structure. It has curved edges, not like 90-degree edges, right? Has curved edges. So here for this thing, if you see, you have multiple grids used, right, to design this. So this is where we use that multi-grid design tool. If you want to make this complex structures, if you see, it's not that simple structure, right? You have something called a snap fit here. So basically, the lid, what you're seeing here, it snap fits on this. So there is a very tight fit which you get compared to other mechanical fits available, like this structures available. So yes, and what else? So here there is a complicated one. An RC tank, right? The chassis for an RC tank. Even this thing is a multi-grid design, if you can see. So this, the left-hand side design, which you can see, it's a chassis for an RC car, uses three grids, like basically three planes to make its design. Individually, we design these things on single plane, three different planes, and we merge it and we extrude it, right? Okay, guys, so we'll just wind up our workshop. Thank you for attending this. Hope this was helpful. If you have any queries, you can reach me out in the WhatsApp group. If you have any issues with your design and you might encounter some issues while designing your own 3D structure, right? So you can contact me there in the group. Okay, thank you. I'll just end the call. Thank you. You can leave.
Do we have any task for this to submit?
Yes, that's what I said. You will get the notification on the WhatsApp group.
Okay.
Thank you.
Thank you.